Hi, hello everybody. So this is the video dealing with section 6.1, law of signs, and this is part two where we go over the ambiguous cases. Now, we may have a situation that depending on the types of sides and angle combinations that we're given, we may get one solution as you see here, and the one solution may be of possibly two types. We have a regular triangle, or we may have a one right triangle. So this is type one. We may have a solution that is a no triangle because one of the sides may be too small. Or the third type, we may have a possible triangle that has two alternatives. So the first alternative would be this side, and this would be the triangle. And the second alternative would be this length. Okay, now notice it's the same length A, but it's just a different angle. And here, this is one of the angles, and in here, this will be the other. So the case with the ambiguous cases for the two triangles is always going to be one has to be a small angle, smaller than 90, and the other is going to be an angle bigger than 90 degrees. Okay, so let's take a look at these three cases. Now, even though we've seen the one solution before. Here, we're going to see the same three cases, but with a different set of inputs that might give the output of maybe two possible triangles or no triangle at all. Okay, so we'll take a look at examples 3, 4, and 5. We'll do 3 first. And again, I'm not providing the picture because on the exam, we're supposed to draw our own pictures, right? So, but as I said before, you just draw a regular triangle, but just keep in mind that now you are most likely going to have to check to see which case you have. Okay, so solve the triangle. Angle A is 43 degrees. Side A is 81. And because this is not really, we're just trying to find which cases we have there, and notice that they're not even giving the units for the sides, okay, which is perfectly fine at that stage. So they're giving us the side A 81, the side B 62, and that's all they're giving. Okay, so notice that different from before where we were given two angles and we could immediately find the third, in this case we cannot, right? And through the law of sines, I only have one full ratio, which is this. So I have to use A sine A, and notice that I don't have anything about C, so I have to use B sine B. All right. And in this case, right, I am giving B, I am giving A, and I have sine of A. So I am going to have to solve uh, this little ratio or equation. I have to solve for sine B. So I'm going to cross multiply, and I'm going to divide by, A. So I'm going to end up with this, right? So I'm going to do a couple steps in one just to save us a little work. So B times sine A over A, right? So you cross multiply. So I'm going to have sine B times A, B times sine A, and then I'm going to divide everything by A. So this is what I have. So I'm going to write it in terms of the numbers that we have. So B is 62. Sine A is sine 43 degrees. And again, once you do this on the calculator, you have to remember that you are in degrees. And we're going to divide by A, which is 81. Okay, now I am going to do this in two steps. First, I'm going to find the value of this thing that I have over here. And here is my calculator. So 62 times sine 43 degrees divided by 81. Now, this is going to be a value. And now we're going to use four digits here, right? This is not an angle or a side. This is the sine of the angle B that we're trying to find. So I'm going to write 0.5220, 0.5220. And now, in order to find the angle B, I have to, um, oops, I have to use the inverse function of sine. So 0.5220. Now, the calculator is going to be an answer for this, okay? So let's do sine inverse. So to do the inverse sine, notice that I have the in blue here, sine inverse. So you click the second function, sine inverse, and 0.5220. And I'm going to get this answer, 3146, okay? So approximately, let's say, and you know what, let's say just 31.4 degrees. That's okay. All right, now here is the thing that you have to be aware. Okay. Um, I have two possible answers whose sine is this value. All right. This is the sine axis, sine x. Um, one, I have 34 degrees, which is right here. I'm sorry, 31 degrees. The other angle is this angle right here because the sine is this segment right here. So this angle is 31.4. So the angle that I'm looking for, the other angle I'm looking for is this. Now, how do I find this angle? This would be 180 minus 31.4. Okay. Now this is what? 148.6. All right. Well, let's just check, but I think it's 148.6. So 180 minus 31.4, 148.6. Okay, so I have two answers and I have to consider them both. We said this before. So this is one, and the other angle is 148.6. Was it 148.6? I already forgot, 148.6. Okay, so now this is what we have to consider. Now, this is obviously a possibility. I have to see if this is a possibility looking at the other angles. Now, why do I say that? Because I have to make sure that A plus B, the angles that we have to be less than 180 degrees. Because if it's already 180 degrees, then the angle C, right, uh, could not be anything bigger than a 0 degrees, and that's not an angle. That's not a triangle. So this is what we're going to do. So you always have to check this. So check. So my angle A is 43. My angle B is 148.6. Now let's add and see what that is. So yes, I know it's obviously, wait a minute, 148.6 plus 43, just 43. Right, so notice it is obviously bigger than 180 degrees, so greater than 180 degrees. Now, what does that mean? It means that this answer here, this triangle with the angle B is not possible. So we disregard it and we only consider the case that B is 31. So it's a little easier for us, but we have to check. So every single time when we have ambiguous cases, we have to check. Okay. Now this becomes a case where I have a single solution. Now, B is already 31. So we go back here, 31.4, and I can immediately find C, right? So C is going to be 180 minus the 43 plus 31.4. So let's find that first. 180 minus 43 minus 31.4. Now, don't really worry about how many decimals you're going to have to do this. One or two decimals is sufficient. So 105.6. So this is my angle C. So I found all of the angles. I have A and B. All I have to do now is C. And to do C, I am going to use one application of the law of sines again. So I'm going to do the same thing here. A over sine A equals C over sine C. Okay. And I am looking for the side C because I already have um, the angle C, which unfortunately I already deleted it. So I'm going to have to check again. So 105.6. Okay. 105.6. All right. So I'm going to multiply both sides by sine C. So C would be A times sine C over sine A. And my side A is 81. My sine C is sine of 105.6. And sine A is sine 43. Okay, so I'm going to go to the calculator, find what that is, and I will be done with the problem. Okay, so 81 times sine of 105.6, always remembering making sure that you are on degrees, otherwise your answer is going to be different. Sine of 43, and this is 114. Now at that point, you remember what I mentioned before, 114 point, what again? Let's say 114.4, okay? If we are doing one decimal, 114.4. Now you have to check that the largest angle has to be opposite to the largest side. So C is obviously the largest angle, and my side C better be the largest side, which it is 114.4, which is bigger than A, which is bigger than small b. All right, so we found all of the angles, we found all of the sides, and we are done with this problem. So this is the one solution case. The easiest case is going to be the no solution case. And we're going to do that now. And you're going to see that this is the case where either the side's going to be too small or the angle is going to be too big and we can't find an answer. All right, so let's take a look at that one. I'm going to erase all of this. You can obviously stop the video. All right, so here is, and I'm going to draw again the triangle the same way as I did before, right? They're giving me the angle A is 75 degrees. The side A is 51 and side B is 71. All right, so again, I only have one angle, so I'm going to have to find the others before I proceed. Okay, now I only have one ratio, which is A, so I'm going to have to use it. So I have to use A sine A. And I cannot do C, right, because I neither have the side nor I have the angle. So I have to use B. So it's going to be B sine B. And I already have sine the side B, so I am solving for sine B. So I'm going to cross multiply and I'm going to divide everything by the side A. So I'm going to end up with sine B is equal to B times sine A over the side A. So sine B is equal to side B is 71. Sine A is sine 75. And side A is 51. Okay, and now we have to find what this thing is first. So let's go to the calculator. So 71 times sine 75 divided by 51. And yeah, I think, All right. So this is now, it could be very confusing. Now you have to remember this is neither an angle nor a side. This is the value of sine B. So I'm going to write 1.34. 1.34. Now, so I'm going to write here again, 134. And now to find this, we use the inverse function, sine 134. Now, the problem is over right here, okay? From here, if you have sine of an angle equals to a value greater than 1, this is no solution. Why there's no solution? Because the largest the sine can be is 1, and the smallest is -1. And where would that be? Well, that would be sine of 90 degrees, okay? So if I do sine of 90 degrees, I get 1. Anything larger than 90 or smaller than 90 is going to be a value less than 1. So for example, if you do sine of, let's say, 90.98, now you might think that this is bigger than 1, but it's going to be a little less than 1. See? 0.99985. So it is impossible to get a sine bigger than 1. If you got this already, that means that there's no solution. And you could try, you could go to the calculator and you can do the sine inverse. So second inverse 1.34 and see what the calculator says, right? So domain error, right? Um, we cannot go beyond 1. Okay, so this is very nice. So if you got a problem like this, it takes you a minute to do, and then we are done. So obviously, it's unlikely that we're going to give you this on an exam or final. But if you got this on a homework, for example, this is as far as you go. If you get a sine of an angle with a value greater than 1, you can stop. So this is the case of a no solution. Now, the next case is probably the most important one, and it takes a little bit longer to do because you have to consider two cases. So I'm going to erase this again, and we're going to do the last case. I'm going to draw the triangle again. And I'm going to call this A. I'm going to call this B, and I'm going to call this C. You could reorder the letters whichever way you want, but as long as, for example, uh, the side A is opposite to angle A, side B is opposite to angle B, and side C is opposite to angle C. Okay? So they're giving us now, so we're saying that this is a two solution. We'll see what that means. So A is 40 degrees. Side A is 54. And side B is 62. So very similar to what we had before. We have a whole ratio and we have to start with B. So I'm going to go A sine A equals B sine B. We've seen this before. I have to solve for angle B. So I'm going to cross multiply, divide everything by A, and I'm going to end up with this. Sine B is equal to B times sine A divided by uh, sine capital A, meaning angle A, divided by side A. Now, B is 62. Sine A is sine of 40. And side A is 54. Okay, so I'm going to get sine B. And I'm going to do this on the calculator. And I'm expecting a value less than 1. Because if I get something bigger than 1 or up to 1, usually you won't get 1 because that would be 90 degrees. But something smaller than 1. So 62 times sine of 40 divided by 54. Perfect. We get a value less than 1, 0.738. Always use 4 decimals here. And you already know to find the angle, we're going to do the inverse. Okay. Now, this is going to give us two values. The calculator is going to give us one, and we have to find the other one. So sine inverse, so second sine for the inverse here with the -1, and 0.7380 or just 8. And the calculator will give us one angle. I am going to say that this is 47.6, okay? 47.6, one decimal only. We have to find the other one. The calculator won't give us the other one. So here's the circle. This is the sine axis. And here is my, let's say 47 degrees, 47.6, 47. This is the sine that corresponds to 47 degrees. The other angle is here, 47. It's this angle. It's this angle here. I have to find it. So how do I find it? It's 180 minus 47. Okay, so the other angle is going to be 180 minus 47.6. And we go to the calculator. You do this in your head. It's not that difficult. 180 minus 47.6. And we get 132.4. 132.4. Now, here's the thing. We know for a fact, even without checking, that this is a possible angle because it's smaller than 90 degrees. So we're fine. We have to see if there's a possibility here for a triangle whose angle B is 132.4. So what do we do? We're going to do to check, right? A plus B. So here's the check. A plus B has to be less than 180. Otherwise, we don't have a triangle. So here's A, here's B, and this is what? 172.4. Yep, it's less than 180. Well, Professor, but it's very high. It's almost 180. I know, but if this is the case, then C is going to be still a valid angle, right? 7.6 degrees. Yep, that's a possibility, right? So this is perfectly fine. So we have to consider both cases. So the check works. Both of these are solutions. Okay. So the B having 47.6 is a solution, and B having 132.4 is a solution. So we have to check on both. Okay, so there's going to be two cases. So I'm going to do first case right here. Okay. This is when B is 47.6. So I'm going to leave it here, 47.6. Now I have to do the work for that. So if B is 47.6, then I can immediately find C by doing the difference from 180, right? So I'm going to do here 180 minus 47.6 minus 40. And let's find out what that is. So 180 minus 47.6 minus 40, and we get 92.4. So C is 92.4. So I have all of the angles. I have two sides. I only have to find side C. All right, so I'm going to do find small c. I'm going to use the A ratio again. So this is A over sine A, C sine C, and I am solving for C. So I'm just going to cross multiply everything by sine C, and I have my answer. So this is going to be A times sine C over sine A, and this is A is 54. Sine C is 92.6. And sine A is sine 40. All right, so let's go to the calculator and find that answer. 54 times sine 92.6 divided by sine 40, and we get, let's say, 83.9. 83.9, whatever units. So I found all of the angles. I found all of the sides. This is done. Now I have to check the other possibility when B is 132.4. Now, don't forget to check, right? Now, angle C is the largest, so side C has to be the largest. So 83.9 has to be bigger than B, which is 62, and right, it is, so we're good. Now, when B is 132.4, so I'm going to change this, and I'm going to reuse this thing. So when B is 132.4, I have to find C the same way. So C is going to be 180 minus 132.4 minus 40. And we're going to go to the calculator for that as we did before, and it's going to be a very small number. 180 minus 132.4 minus 40. It's going to be a small angle, but it's still okay. This is the 7.6 we discussed before, which is still an angle, which is perfectly fine. Okay. I still have to find C, side C, if C is a small angle, and I'm going to use the exact same thing as I did before. A sine C sine A. It's the same ratio. It's exactly the same thing. But now your angle C is no longer this. It's the 7.6. Okay. So sine of 7.6 over sine of 40. And we can go to the calculator for that. So 54 times sine 7.6 divided by sine 40. And we're going to get 1111 or 11.1 if we're just doing one decimal. And again, because C is the smallest angle, it has to be opposite to the smallest side. So C has to be the smallest, which it is, right? It's smaller than B, 62, it's smaller than A, 54. So we're good. So this is the two-case solution. It's a little bit more work, right? Because you have to do it twice with the possibilities here, right? Both when you find one of the angles, you're going to have two angles, and they will both work. Meaning, this angle plus the other angle that you have is going to be less than 180 degrees, and the 132 plus the other angle that you have is going to be less than 180 degrees. So if that's the case, you have two possible solutions. You have to find them both. And we did. So this is the other case. Now, the only application that we're going to see is going to be related to these cases. So here's one example from your book. They are all identically the same, done the same way. And you may have a solution that is a one solution triangle. You may have a solution that is no solution, or you may have a solution that offers you two possible triangles. It all depends, but the application is all the same. Usually for these verbal problems, we will give you the picture, right? Especially because some of the wording may be confusing and complicated, so we'll give you the picture. In this case, the problem says the Leaning Tower of Pisa in Italy leans at an angle of about 84.7. So here is the angle with the tower and the x-axis. The angle of elevation, which you have to remember, is this. To the top is 50 degrees. And they want you to find the distance. Now, these application problems they're much easier to do. Because when we are asked to solve a triangle, you have to find all angles and all sides. These application problems, you're only going to have to find maybe one or two things. That's it. In this case, find the distance to the nearest foot from the base to the top of the tower. So what is it that they want you to find? From the base to the top of the tower. So they just want you to find this. I don't need to find this angle. I don't need to find this side. I just need to find B. All right. Now, you cannot use the properties of right triangle trigonometry because this is not a right triangle, right? It's 87. So you have to use, now you only know the law of sines, but after we cover section 6.2, you could either use the law of sines or the law of cosine. In this case, I have to use the law of sines. Now notice for the law of sines, I have to have one complete ratio. Now I don't have this angle, so I have to find this angle first. So this angle is 180 minus 84.7 minus 50. And I'll go to the calculator and we'll find that angle. 180 minus 84.7 minus 50, and I need that to form a complete ratio, so this is 45.3. 45.3. Now I have a complete ratio. Okay. So what can I do? Well, here is one complete ratio. Okay, so I'm going to say C over sine C. And here is the B that I want. It's opposite to 50. So B sine of B. I am solving for B, so I'm cross multiplying everything by sine B. So this is going to be B equals C times sine B over sine C. And now C, what is the value of C? 171. Sine B is sine 50. And sine C is sine 45.3. All right, so approximately, let's go to the calculator for that. So 171 times sine 50 divided by sine 45.3, and we get 184.29. 184.29 or 124.3, doesn't matter. This is in feet. So you make sure that you write feet over there. And that's all I have to do. So notice, I don't need to find this. Okay, it's not necessary. So these application problems are usually much, much faster than solving a triangle. That takes a little bit longer because you have to find all angles, all sides. Okay, so this is the end of our case where we applied the law of sines for the ambiguous cases. So again, three possibilities: one triangle, no triangle, or two triangles. And all we have to do is apply the same properties.